Welcome to section 10.2 part 2, Pascal's triangle and binomial coefficients. In this lesson, you will learn to create Pascal's triangle. You will also learn to expand any power of a binomial and to find the coefficient of specific terms in a binomial expansion. Pascal's triangle is named after the French mathematician Blaise Pascal. However, the mathematics behind the triangle had been discovered in many other cultures, including India and China and Greece and lots of them, and been utilized there for some time, centuries. Pascal's triangle is a triangle where each element is the sum of the elements immediately above it. And that actually doesn't make sense when I say it like that, but let me just show you what it looks like. So, notice that each new element is being formed by summing the elements directly above it. Let's just view that again. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 1 is 3, 3 plus 1 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and so on. In fact, if we look up at this, we can see that that carries on. For instance, 1 plus 4 is 5, 4 plus 6 is 10, and so on. And this carries on forever. By convention, and this will actually make a lot more sense when we start to look at what we can do with Pascal's triangle, the very first row in Pascal's triangle is called row 0. That's this one here. And the second row is called row 1, and so on. We count up from there. Pascal's triangle is really formed by combinations where the row number is the size of the set that we're choosing the combinations from. So in other words, in row 0, that's the number of ways that we can choose 0 things from a set that has 0 things in it. Basically 1. In the second row, the first number 1 is the number of ways that we can choose nothing from a set that has 1 element. Well, we've already said that the way that you can choose nothing from a set is one way. You just don't take anything. The second element in that row is the number of ways that you can choose 1 element from a 1 element set. That's also 1 because if I've got one thing to choose from, there's only one way that I can take that one thing. The second row is the number of ways that I can choose things from a 2-element set. So this number 1 here, that's the number of ways that I can take nothing from a 2-element set. Again, that's one way. The second element here is the number of ways that I can take 1 element from a 2-element set. So either I take the first thing or I take the second thing. There's 2 ways to do that. And finally, this other one is the number of ways that I can take 2 elements from a 2-element set. There's only one of those. I can take both of them. That's the only way to do it. And so on. One of the primary uses of Pascal's triangle is to calculate the coefficients of binomial expansions. What I mean by a binomial expansion is taking a binomial like this one, x plus a, and taking it to some power, and then expanding that outwards. So the way this works is this. We look at the power that our binomial is taken to, in this case, in example A, 3. And then we go to row 3 of Pascal's triangle, and these 1, 3, 3, and 1 will be the coefficients of the terms in the binomial expansion. So, here's the way it works. There's a coefficient that comes from the Pascal's triangle, and then we'll have a to the 0th power times x to the 3rd power plus, and here comes our second coefficient, and then we'll have a to the 1st power x to the 2nd power plus, here comes our third coefficient, and then we'll have a to the 2nd power x to the 1st power plus, and here comes our final coefficient, and then we'll have a to the third power, x to the 0th power. So what goes in these slots are these coefficients. So that's going to be 1, 3, 3, 1. So when we're all said and done, expanding x plus a cubed is going to give us 1. We don't need that. A to the 0 is 1. So that's just going to give us x cubed. Plus 3, a to the first power is a, x squared, plus 3a squared x plus a cubed. So the way that we deal with the powers of our terms is we take a to the 0th power in the first term, a to the first power in the second term, a squared in the third term, and a to the third power in the fourth term. And then we do the exact opposite with the other term in our binomial, the x. We start off with x cubed, then we go to x squared, then we go to x to the first power, and then we go to x to the 0th power. So in other words, one of the terms in the binomial is counting up, the other term is counting down. Let's try this for the bigger powered binomial, and also one that's got a minus sign between it, because that makes things a little bit more confusing. For this, because I'm taking it to the 6th power, I'm going to use the 6th row of Pascal's triangle. And I'm going to start off with the first coefficient in that row, that's 1, and I'm going to multiply 1 by negative 1 to the 0th power. And I'm going to multiply that by x to the 6th power. There's my first term in my binomial expansion. Now I'm going to add my second term. Well, the second entry in Pascal's triangle is 6. So it's going to be 6 times, and now I'm counting up on powers of negative 1. Before I had negative 1 to the 0th. Now I'm going to do negative 1 to the first. And then I'm going to multiply that by a power of x. Before I used x to the 6th, now I'm counting down, I'm going to use x to the 5th. Alright, and now I'm going to go on to my next term. And my coefficient's 15, so I'm going to do 15 times negative 1. Now I'm going to go squared, because before I did to the first. And I'm going to multiply that by x to the 4th, because before I did x to the 5th. It's a 4, not a y. Alright, and then I'm going to go on to my next term, plus, and I'm going to fast forward here and just fill out the rest of the terms for you. Okay, and I've filled these out. So, let's actually do some simplification here. Negative 1 to the 0th power is 1. Anything to the 0th power is 1. 1 times 1 is also 1. 1 times 1 times x to the 6th is just x to the 6th. So my first term is just x to the 6th. My second term, 6 times negative 1 to the first power. Well, negative 1 to the first power is negative 1. So really this is plus negative 6 x to the 5th. And then plus, well, negative 1 squared, that's positive 1. Positive 1 times 15 is 15. X to the 4th. And in fact, every time I have an even power of the negative number, I get a positive number. And every time I have an odd power of the negative number, I get a negative number. And so I'll just fast forward and fill this thing out. And there we have it. Now, I can take these plus minuses here, and here, and here, and just turn them into a minus, right? That would be as simplified as you could get with this. What if we were only interested in a coefficient of a specific term? What if I want to find the coefficient of the x cubed term in this binomial expansion here? 2x minus 3 to the 8th power. Well, we'd like to use Pascal's triangle, but in my picture, I only go up to row 7, and I know that I need row 8. What can we do? Well, we could make the next row in Pascal's triangle. We know how to do it. We know that our outside number is 1, and that we sum the numbers immediately above our next entry. So, in other words, this entry is going to be 8, because above it we have a 1 and a 7, and those add up to 8. And the entry after that is going to be 28, because 7 plus 21 is 28. And the next entry is going to be 56, because 21 and 35 is 56. And our next entry is going to be 70, because 35 plus 35 is 70. And then we can see we've kind of got a mirror image. In fact, that's something you can notice about Pascal's triangle in general, is that it's symmetrical. So this entry is going to be 56. This entry is going to be 28. This entry is going to be 8. And that entry is going to be 1. So we want the coefficient of x cubed. Well, this one here is the coefficient of x to the 8. This one's x to the 7th, x to the 6th, x to the 5th, x to the 4th, x cubed. So we know that we're going to have 56 in that, right? And then we're going to take 2x, that's what's cubed, right? And then we're also going to be multiplying that by negative 3 to some power. Well, what is that some power? Think about what we're doing here. We'd start off with negative 3 to the 0th, negative 3 to the 1st, 2nd, 3rd, 4th, 5th. Alright. And then once we've got all that together, that's going to be our coefficient. So we're going to need to do a few things. One, we've got the 56. We just took that straight out. The other is, we're going to have 2x cubed. Well, the cubed has to be distributed. So what's 2 cubed? That's equal to 8. Then we've got negative 3 to the 5th. Well, my goodness, I don't know what 3 to the 5th is off to the top of my head, so I'm just going to have to go 3 to the 5th. 243. And of course, it's negative 3 to the 5th. That's an odd power. So this is going to be times negative 243. And again, I'm going to rely on my calculator here because those are a lot of numbers that I don't want to multiply in my head. Which is negative 108,864. Alright. So, we've learned how to build Pascal's triangle and how to use it. Specifically, we've learned how to use it to expand binomial powers and find binomial coefficients. See you all in class.